Good day to the respected judges, ladies and gentlemen. My project is entitled Ways to Green Eco-Construction. I am Rahini Saishri Surendran from SMK King George V, Seremban, Negeri Sembilan. For Norma Warni is my teacher advisor and Mr. Surendran Mirasamy is my mentor. I had the privilege to collaborate with Mila University Nilai, University Putra Malaysia and DU Fiber. Let's start with the problem statement. The problem we are facing is the over-reliance to natural materials. Nowadays, bricks available in the market usually consist of natural resources such as clay and sand. The cost of building materials are escalating as well. We may no longer be able to sustain those raw materials such as limestone. Limestone is often used in the production of cement. In addition, the severity of plastic pollution is also increasing. This not only destroys the marine system and land ecosystem, but also contributes towards the greenhouse effect and global warming. My suggestion is to produce my prototype eco-bricks. This is in line with the UNDP's Sustainable Development Goals, Goal 9, Industry, Innovation and Infrastructure, and Goal 13, Climate Action. I aim to use both organic and non-organic materials to reduce the amounts of sand and limestone in the bricks. This correlates with the aim of Goal 9, to build resilient infrastructure, promote inclusive and sustainable industrialization, and to foster innovation. I used paddy husk waste and coconut husk waste to substitute cement. I also aim to reduce the amount of recycled plastic, such as HDPE and PP plastics, as these are more readily available, by substituting sand with plastic. This is related to Goal 13, Climate Action, as we are able to reduce the production of single-use plastics, which emits vast amounts of greenhouse gases. With this in mind through research findings, I decided on the production of 3 types of eco-bricks and an additional 4 types as part of my continued research. The Malaysian Standards 7.6 1972 and British Standards BS 3921 1985 were followed as guidelines in the production and testing of the bricks. Ladies and gentlemen, these are the processes involved in the making of eco-bricks. First is the mold making process, followed by burning of the paddy husk to ash, crushing and separating the carbon from the ash, crushing and shredding the plastic, preparing the different mixture ratios, pouring the mixture ratios into standard measurement molds, and curing of the construction materials and samples for 7, 14, 21 and 28 days. The diagram shows the 7 mixture ratios that I had utilized in my experiment. There are 3 common requirements the bricks have to comply with: the absorption rate, compression strength, and efflorescence. However, as part of my continued research, I decided to add the fire resistance test. For the absorption test, the bricks were soaked in water for 24 hours and the mass of the bricks were measured before and after soaking. This is the formula in calculating the absorption rate. The absorption rate cannot exceed 20% as the bricks will not be suitable for construction. Next is the compression strength. The top loading method was used to test the specimens which were cured for 7, 14, 21 and 28 days. This is the formula in calculating the compression strength. For the efflorescence test, the bricks were partially soaked in water to the height of 20 mm and the water was left to evaporate. The cycle was repeated. Once all of the water had evaporated, the bricks were checked for efflorescence scalings and flakings. This is more of a visual check. This is how we define the efflorescence scalings and flakings: none or nil, slight, moderate, heavy or serious. And finally is the fire resistance test, which is a visual test. It involves the exposure of my bricks to a flame source to test for load-bearing and fire-separating properties for the regulated use in buildings. In this case, the flame of the Bunsen burner was applied for a specific time with a temperature of approximately 1500 to 1600 degrees Celsius. I only did a simple test because UKM, Mila University and UPM did not have the facility to carry out the test. The distance or time the flame propagates were measured. Then, the linear burning rate was measured in millimeter per minute. These are the results for the 7 mixture ratios. These are the comparisons for the compression strength. From the results, both the MS and BS standards can be referred for load-bearing application. The BH cement bricks and the BH HDPE bricks can be classified as first-class bricks. The rest of the bricks can be classified as common building bricks. However, the PP cement bricks has a very low compression strength and does not fall under any classification. Meanwhile, these are the comparisons for the absorption rate. From the results, our finding is that the BH cement bricks and the HDPE cement bricks have medium absorption rates and can be classified as first-class bricks. The rest of the bricks, except for the PP cement bricks, can be classified as heavy-duty machine-made bricks. The PP cement bricks can be classified as second-class bricks. The lower absorption rate of the brick will not dry the cement plastering or layer too quickly and allow natural curing. it will consume less undercoat or paint. The prototype can be further developed to produce roof tiles, pavement blocks, floor tiles and wall tiles. With proper funding and research support, we can further develop the use of recycled materials, both organic and non-organic, to create new construction materials like jute, cane and coconut fiber to replace the paddy husk. We can also use recycled oil such as engine oil and gear oil to act as replacement material for the construction of flexible pavement. Our target market would be housing development, hardscape and landscaping contractors and export to third world countries. This is also related to Goal 12, which is sustainable consumption and production. Reports from UNDP show that the progress in least developed countries is far from sufficient to reach the target of doubling the manufacturing shares in GDP by 2030. However, this innovation has the potential to aid those countries in the development of infrastructure, as it only uses organic and non-organic materials which are abundant in those countries. The price expected to be marketed at would be 15 cents for PP cement bricks, 20 cents for PH HDPE and CH HDPE bricks, 25 cents for HDPE cement bricks, PH and CH bricks, and 30 cents for PH cement bricks. The list provided here is the comparable market price for the bricks sold currently. All materials can be used for construction, except due to the low compression strength and extremely high absorption rates, the PP cement bricks cannot be classified as load-bearing bricks. The PH cement bricks and PH HDPE bricks can be classified as first-class, heavy-duty and load-bearing bricks. The rest are classified as common building bricks. PH, CH, PH HDPE and CH HDPE bricks have low absorption rates. The PH cement bricks and HDPE cement bricks have moderate absorption rates. All of the bricks had a fire rating of at least 1 hour. The test was not carried out for more than 1 hour due to fire risk. All bricks showed no signs of efflorescence. There is a big market for this product where we can contribute towards the recycling of plastic and waste materials while sustaining the natural resources. The product has a commercial value as it complies to the standards. It is easy to manufacture and does not need complex machinery. The product is also durable, strong, and can be produced at a competitive price. The best part is it is light in weight. These are some of the research references I used in my project. Before I end, I would like to thank our collaborators, University Putra Malaysia, Mila University Nilai, and DU Fiber Sendirian Berhad, my teacher advisor, and my mentor.